Hi everyone, this is a lesson on average value and mean value theorem for integrals. So the average value of a function on the interval a, b is given by this formula, 1 over b minus a, the integral from a to b of f of x dx. So let's use that formula to find the average value of f, which is this 1 plus x squared on negative 1 to 2. So this right here is your a, and this right there is your b. b minus a for this problem is 2 minus minus 1, which is 3. And so my f average is quite simple to do. It's 1 over 3, the integral from negative 1 to 2 of f of x, which is 1 plus x squared, dx. So once you set up the integral, we're just doing the antiderivative. So 1/3 stays out front, and then the antiderivative here is x plus x cubed over 3. Put the brackets on from negative 1 to 2. Okay. All right, now we have to put the top number in. So we get 2 plus 2 cubed over 3. And put that all in parentheses, the top number, right, being put into the antiderivative equation, minus, and now be careful here, negative 1 plus negative 1, the quantity cubed over 3. This is like the bottom number being put into the antiderivative equation. So now for problems like this, it's good to just kind of open up all these parentheses without simplifying first, because a lot of things might cancel out. So we have the 1/3 that's here, and that's going to stay out front. And then I have 2 plus 8/3 plus 1, okay? This negative 1 cubed right here is negative 1 times this negative makes a positive. So I'll have plus 1/3. And now you can combine, like this 8/3 and this 1/3, that makes 9/3 or 3 over 3. I mean 3, not 3 over 3, just 3. And this 2 and 1 combined to make 3. So I'm going to end up with 3 plus 9 over 3, which is 1/3 of 6, which is 2. That's going to be my average value. So we're saying the average value of this graph, 1 plus x squared, on this interval, negative 1 to 2, is equal to 2, right? And that's really a statement about the average y value. We know that 1 plus x squared, right? Let's see if this makes a little sense. 1 plus x squared is the parabola, so it's a parabola shifted up, and that's going to look something like this, right? So what we're saying is that if you go from negative 1 to 2 to positive 2 on that stretch, right, on this parabola, we've got all these different y values, right? The average of those is equal to 2. Okay, the highest one is right here at 4. Okay, and the lowest y value is right here at, actually lowest one is right here at 0, but the average y value is right there at 2. F average is equal to 2. Okay, let's do another one. So here we're finding the average value of sine of x on the interval from pi over 6 to 5 pi over 6. So we're going to write our equation again. F average is equal to 1 over, here we have an a of pi over 6 and a b of 5 pi over 6. So b minus a is equal to 5 minus 1, right? 4 pi over 6 or 2 pi over 3. Recognize that when you do 1 over b minus a, that's going to become 3 over 2 pi. The pi goes in the denominator here when you flip this fraction. 1 divided by this 2 pi over 3 becomes 3 over 2 pi. So now I have 3 over 2 pi, right? And then we have the integral from pi over 6 to 5 pi over 6. And then the function sine x dx. So the antiderivative of sine x is negative cosine x, and I need to go from pi over 6 to 5 pi over 6. So this negative can come out front here just to simplify things. So I'll have negative 3 over 2 pi, and then I'm doing cosine of 5 pi over 6 minus cosine of pi over 6. Cosine of 5 pi over 6 is, it's 150 degrees, right? So we're here, right? And that's equal to negative negative rad 3 over 2, and cosine of pi over 6 is the same, so, but it's positive rad 3 over 2, but this negative is going to make it negative. So here now, I can pull out a negative sign, so I have 3 over 2 pi, and then I have rad 3 over 2, and there's 2 of them, so it's like rad 3 over 2 times 2, which is rad 3. So my final answer is 3 rad 3 over 2 pi. Okay, something important is not to confuse average value with average rate of change. So let's make sure we understand the difference. If we're talking about average value, which is what we just did, right? So here's a function, and say you're going from A to B, right? Average value really means we're trying to find the average y value of this function, and we do it by finding the integral that we just talked about. So f average is equal to 1 over b minus a, the integral from a to b of f of x dx. That's average value. Average rate of change, right, that's a different thing. Average rate of change of f is not about the y values and finding the average. It's literally about finding the slope between this point right here and this point right here. It's the slope of the secant line. So average rate of change is the slope of secant line, and that is going to be a very different thing. It's f of b minus f of a over b minus a. Average value is this integral that we talked about. So please keep those two things separate and clear in your mind, right? Average rate of change of f versus average value of f on an interval a to b. The two of these are related, in terms of physics, where if you think of a velocity function, right, then the average velocity from time a to time b, average velocity would be the integral 1 over b minus a, integral from a to b, v of t dt, right? Now, when you think about taking this integral, so then, we're thinking of our ladder, and we know that the derivative of position is velocity. The derivative of position is equal to velocity, but the integral of velocity is therefore equal to position. So then I have 1 over b minus a, and the integral, right, or the antiderivative of velocity is s of t from a to b. And when I put the b and the a in, I'll just end up with s of b minus s of a over b minus a. So we're seeing here that these two ideas of average velocity, right, average velocity, that's that new integral equation, right, the f average equation, right, is going to be related to average rate of change, not of velocity, it's going to be average rate of change of position, right? So average velocity is equal to average rate of change of position. But if you did a secant line calculation on a velocity graph, if I did this secant line here, right, if I do v of b minus v of a over b minus a, then this is the average rate of change of velocity, which is the acceleration, right? So we just want to keep these things clear in our minds. Okay, let's move on to another example. So here we are trying to find an average value of a piecewise function, right? Here's a piecewise function. And this one happens to, we can even sketch this one. It's really not too bad to sketch, right? We have x plus 1 is the graph for x less than 0, so that's just a line, right? And then on the other side, we have cosine of pi x, so that thing will have a amplitude of 1 and a period of 2 pi divided by pi, or 2. So this is going to look something like, this cosine graph is going to look something like that, okay? And we're looking for the average value of this function from -1 to 1, right? So on this stretch. So We didn't have to sketch it. I just kind of used this as an opportunity to review how to sketch a piecewise function. But we're just going to do f average, the same formula. So the formula is 1 over b minus a. In this case, here's my a, here's my b. So it's 1 over 2 integral from -1 to 1 of f of x, right? Now, f of x is a piecewise function. So we're going to have to break up this integral because the rule for f, right, if you look at the rule here, for x less than 0, we have one rule, and then for x greater than or equal to 0, we have another rule. So we're going to split up our integral at 0. So I will integrate here. 1/2 is going to be a factor outside, and then I'll split the integral from -1 to 0 plus from 0 to 1. Okay, and now I will use the appropriate rule. So I go 1/2 integral from -1 to 0 of x plus 1 using the gray rule, plus then when I come into the red x's for greater than or equal to 0, so going from 0 to 1, I'm going to use the red rule, cosine of pi x dx. Okay. So then I just have to do those two antiderivatives, and we'll do our usual things, finding the antiderivative. So x squared plus 1 plus x from -1 to 0 plus, and now we have cosine of pi x. You can do a little u substitution. So if we say u is equal to pi x, and then du dx is equal to pi, and dx is equal to du over pi, then that second integral right here, this integral, can be rewritten as the integral from, it's the integral of cosine u, and then the dx becomes du divided by pi. The pi is going to come out front. The limits on the integral are u, so if x is equal to 0, u is equal to 0, and if x is equal to 1, then u is equal to pi. So this would go from 0 to pi, and this will end up being 1 over pi sine u from 0 to pi, which will be 1 over pi times sine of pi minus sine of 0, which is all 0. So this is going to come out to be 0. You can also kind of just realize that from the symmetry of this integral. But anyway, the u substitution be one way to do it. The other way to do it would be just to realize that, the antiderivative of cosine of pi x, we've seen this kind of pattern a lot of times. So you could maybe even remember that the antiderivative is going to work out to be 1 over pi sine of pi x, and then you could do it with the x limits on the integral. Either way, we're going to get 1/2. This first piece is going to be 0 plus 0 minus, careful with the -1, the quantity squared, minus 1. And then the second integral we already talked about, that's this guy here, and that was 0. So final answer is going to be 1/2 times another 1/2, which makes 1/4. That'll be my answer. Okay, let's finish up with the mean value theorem for integrals. So the mean value theorem for integrals, not to be confused with the mean value theorem for derivatives. The mean value theorem for integrals says that if a function is continuous on AB, then there exists a number c, and this is an x value, right? So we're saying there exists a number x, which is called c, in this interval AB, such that f of c, meaning the y value at that x value, is equal to the average value of the function on the interval from a to b, right? And the average value is, of course, this integral that we've been talking about. So what does this all mean? Well, it just means that when you find this average value on a stretch from a to b, there's going to be at least one place where the function y value is exactly equal to that average value. So for example, example 4 says, find the number guaranteed by the mean value theorem for integrals, right? So this number is the c. and then the function is f of x 1 plus x squared, and we're on the interval -1 to 2. This is the exact same problem as we did in example 1, right? So we have 1 plus x squared, that's my parabola, and I'm going here from -1 to +2. So I'm up here at like 2 comma 5, and -1 would be -1 comma 2, and I'm looking here at this stretch, okay? And we found in example 1 already that the average value, f average, if you do the integral 1 over b minus a integral from a to b of f of x, which is 1 plus x squared dx, we found out that this was equal to 2, right? So we've got this average value, Faith. Okay, so that means that here at, if I just were to draw a flat line at that average value, that would be that red line. Okay, so you can already see from the picture that the function is the parabola, right? This function reaches that y value twice, once here and once there. And those are the places that are being called C, and our job is to find those places. So we simply take the function equation, and we say 1 plus c squared is equal to 2, right? I'm calling my x that I'm going to be solving for c, and I'm using this average value here, right? This is f average. So then I just solve this. C squared is equal to 1, c is equal to plus or minus 1. So we're saying that at these two places, at x is equal to -1 and at x is equal to 1, the function y value is exactly equal to the average value. Okay, our last problem here is find the average value of f of x equals 2 sine x minus sine 2x on the interval 0 to pi. So we're going to use our calculator and practice Math 9 to do this problem. But I want to remind you that when you do a calculator problem, you always want to start by writing down what you're putting into the calculator onto your paper, right? So here I'm going to be putting this integral into my calculator, but I first want to write it on paper. So I will say f average is equal to 1 over b minus a. B minus a will be pi. And then we're integrating from 0, from a to b, 0 to pi. 2 sine x minus sine 2x is my integrand, and it'll be dx. Okay, and now we turn to our calculator, and we're going to practice doing that. Okay, so let's see how we do this in our calculator. You want to make sure that your calculator is in radian mode, right? So check that at the top. And then we're going to use Math 9. And we're going to integrate from 0. You can put pi in there, right? You just go second hat, and you get the pi at the top. And then we go sine of 2x minus 2 sine of x. Actually, this was the other way around. Sorry, 2 sine of x. Make sure you close that parentheses. Minus sine of 2x. Make sure you close that parentheses as well. And then the whole integrand, right, will be in an outer set of parentheses. And then we're saying dx. Okay. Hit enter to get the integral value, which is just 4. This is one actually that you could do by hand as well. But now remember, this is just the integral, and we have to now divide by the b minus a, right? So if you needed a decimal answer, then you would just divide that number by pi, which is the b minus a. If you don't need a decimal answer, then, well, you would just write 4 divided by pi. Okay, so this answer came out to be 4 over pi. That would be for a no cal. You know, if you were doing that as a multiple choice or something, you might see that answer. Or if you didn't have a calculator, you would write it like that. With our calculator, our answer will be written to 4 decimal places as 1.2732. Okay, so let's pause the video and do the takeaways, please. Okay, this first takeaway, my apologies, but there shouldn't be a blank here. It should just say the average value of f on AB, right, is equal to the integral that we learned, 1 over b minus a, integral from a to b of f of x dx. Okay, then we want to remember that average velocity is the average rate of change of position. So if you're doing an average rate of change, then that's the secant line slope. So the average velocity is the secant line slope on the position graph. The average acceleration would be the secant line slope on the velocity graph, okay? So those are average rates of change, and we wanted to make sure that we don't confuse those with average value, right? So remember that. In terms of equations, we're saying average velocity is 1 over b minus a integral from a to b of the velocity. This is equal to s of b minus s of a over b minus a. So if you're given a position function and you're finding average velocity, you're doing the average rate of change. If you're given a velocity function and you're finding average velocity, then you're doing the average value integral. Okay, mean value theorem for integrals, that's number 5 is what we learned today. Just reviewing here the mean value theorem for derivatives, that's the one that said that if a cop knows your average velocity on a stretch of the highway, then he can ticket you even if he didn't know your exact velocity at all times during that drive. And the reason is because of the mean value theorem of derivatives, which says that if f of x is continuous and differentiable on a stretch AB, then there is some x is equal to c on AB, where the instantaneous rate of change, right, this is the slope of the tangent line or the derivative, is equal to the average rate of change on that interval. So f prime of c is equal to f of b minus f of a over b minus a. That's all about, saying if you have a graph from A to B, then the slope of the secant line from A to B will be matched by the tangent line slope at least once along the way, okay? Mean value theorem for integrals is what we learned today, and that one says that if f is continuous, you don't need to be differentiable for the mean value theorem for integrals, then there will be some number c on AB such that f of c is equal to f average, and f average is, of course, the average value integral. So I hope you had fun learning these new things, and I can't wait to tell you more in the next video.